So in this tutorial we'll be looking at nuclear decay equations. We're going to be looking at what happens to the nucleus when it undergoes alpha, beta and gamma decay, and then we're going to learn how to balance nuclear decay equations. Remember to use the pause button. A full set of the notes is available with this link via the Google Classroom. Bring any questions to the next lesson. So if we look at alpha decay, first of all, we remember that an alpha particle consists of 2 protons and 2 neutrons. And that's the same as a helium nucleus. And because these are being ejected from the nucleus, that means that when a nucleus undergoes alpha decay, it causes the mass of the nucleus to decrease and the charge of the nucleus to decrease. So the mass decreases by 4 and the charge decreases by 2. Now we can use equations that need balancing, just as they would in chemistry, to represent this process. In this process we're going to represent an alpha particle with this notation, He, 4 and 2. And you can see that we've used that in the equation over here. So let's have a look at this equation and see how we found it. Now if we have a look at this equation here and what it's telling us that an unstable radon nucleus with 86 protons and 219 protons and neutrons decays and turns into a polonium nucleus with 84 protons and 215 protons and neutrons, and a alpha particle with 2 protons and 4 neutrons and protons. Now the really important thing is that these numbers on the top all balance and that these numbers on the bottoms all balance. So let me show you what we mean. If we had 86 protons to start with, and that radon turns into polonium that's only got 84 protons, then I need to make sure that I've got 2 protons somewhere else. So 84 plus 2 equals 86. So we say that this part of the equation is balanced, and that's a good thing, because otherwise the equation is wrong. And we can look at the top and balance the top numbers as well. So 219 goes into 215 plus 4. 215 plus 4 equals 219. So this equation is balanced. Now what you might be asked to do in an exam style question is to fill in some missing numbers. So the question could look a little bit like this. If we have radon turning into polonium, and the question might say radon with an atomic number of 86 and a mass number of 219 undergoes alpha decay and turns into polonium. Write an equation for this nuclear decay process. So what we do is we write out what we know. Radon with an atomic number of 86 and a mass number of 219 turns into polonium and it undergoes alpha decay. So then we know that we have to write in the alpha decay particle, so helium with 4 and 2. And then, because we've got these numbers here, because I've got these numbers and these numbers, I can work out what these numbers should be. So let's put those in now. So I say, right, 219 turns into something plus 4. So I know that's got to be 215. And 86 turns into something plus 2. So that's got to be 84 there. And that way I can make sure my equation is balanced. So if we now look at beta decay, we've seen this symbol for beta previously. Beta decay happens when a neutron turns into a proton. Now because we've gone from a neutron into a proton, there is no change in the mass of the atom because you've got the same number of neutrons and protons you had before. But what it does mean is that the charge of the nucleus has increased because we've gone from having a neutrally charged particle to a positively charged particle. So beta decay does not cause the mass of the nucleus to change, but does cause the charge of the nucleus to increase. Now, in a nuclear decay equation, we represent a beta particle with this terminology here. We've got an electron, There's no protons or neutrons on it, but it has a charge of -1. And if we look at this equation underneath, we can see that this equation follows the same rules as the previous alpha decay equation in terms of making sure that everything is balanced. So I've got 14 goes to 14 plus 0, so that's balanced, so that's fine. And I've got 6 turns into 7 plus -1, so that's balanced. So this equation is absolutely fine. And again, if you were thinking about an exam style question that you might have, you might be told that carbon 14 undergoes beta decay, and you might have to write a balanced equation. So you start off writing down the things that you know. So you know that you've got carbon 14, that's got 6 protons. And the 6 protons would be hidden somewhere in the wording of the question. That's why you've got to bug the question so carefully. We get told it turns into nitrogen, and it emits a beta decay particle, so then we put in our notation for our beta decay particle, and then we have to balance the equation to make sure the numbers add up. So 14 goes to something plus 0, so that's going to be 14, and 6 goes to something plus -1. This one you need to think a little bit more carefully about if you find positives and negatives a bit tricky when you're in a fluster, and that is then a 7. Gamma decay, so the emission of a gamma ray from the nucleus does not cause the mass or the charge of the nucleus to change. You don't have to be able to write a nuclear decay equation for gamma emission, and it's worth bearing in mind that obviously the gamma ray is emitted from the nucleus, but it normally accompanies either an alpha decay or beta decay emission. So you'd normally get alpha decay and some gamma, or you'd get beta decay and some gamma. So that's the tutorial on decay equations complete. Make sure you've got the notes complete in your exercise book. Use the pause button where necessary, and we will try some exam style questions in the lesson. The full set of A4 notes is available through the link with this video. Make sure they are all up to date.